CVE 2025-21756 is a high-severity use-after-free vulnerability in the Linux kernel's vsock subsystem. It allows an attacker with local rights to trigger a kernel memory corruption during socket binding, potentially leading to privilege escalation or denial of service. The issue was introduced in early vsock code and fixed upstream in kernel version 6.3. Affected products include Linux kernel versions before 5.5, git commit C0CFA2D8 through various upstream commits, and any distribution using an unpatched vsaota implementation. Unaffected versions start from 5.10.235, 5.51.79, 6.1.131, 6.679, 6.12.16, 6.13.4, and any latest 6.14 series release containing the original commit for the fix. This is a kernel-level use after free vulnerability in the vsock virtual socket transport. The flaw manifests when socket objects are unbound prematurely, leading to reef count underflow and potential execution of code on freed memory. It can be classified as memory corruption with a high risk of local privilege escalation. The issue occurs in 3 steps. 1. vsock allocates and inserts a socket into the unbound list, bumping its ref count. 2. During a transport reassignment, transport release calls vsock remove bound without checking if the socket was already bound, dropping the ref count to 0 and freeing the SK object. 3. A subsequent vsock bind assumes the socket is unbound, calls vsock remove.bound, a no-op on the freed list node, and then drops to vsock insert bound which reads and writes fields on the freed ISCI. Kernel address sanitizer reports a slab use after free and reef count underflow. An attacker who can open and bind vsock sockets can reliably trigger this, leading to arbitrary reads or writes in kernel space. All Linux distributions using vsock should apply the vendor patch or upgrade to a kernel version that includes the fix 6.14 or later. Administrators are advised to audit any virtualization or container hosts exposing the vsock interface. Timely patching is critical to prevent local privilege escalation or system instability.